Oh, sorry about that. Is that time already? Hope you enjoyed your Easter. I'm still working on enjoying mine. Good stuff. Anyway, hey, welcome to Algebra. We are continuing our work on completing the square. This is completing the square part 3. Another situation. We've been looking at some basic x squared plus something x plus 16, right? And figure out what that middle term has been. We've been using those, but we're going to change it up just a little bit today. And we're going to add some coefficients in front of that x squared, which we haven't really done. So let's get switched over and get ready to go here. All right, let me get turned around, situated. Make sure I'm in focus. You can see my lovely chocolate face today. All right, completing the square, part 3. All right, perfect squares in 2 forms. So Elena says, here's what I make sure you're in focus too. All right, x plus 3 squared can be expanded into x squared plus 6x plus 9. We know that's true because we get this last number by taking that 3 and multiplying it by itself, remember? And the 6x, we would get the 3 times the x, really, the 3, and we would double it. We would have 2 3's, and it would be a 6x. So that's how we got that. So she says, since that's true, 2x plus 3 can be expanded into 4x squared plus 6x plus 9. So since she's got 2x times 2x would be 4x squared. She says that's how that would work. She's close, but she's missing a step in there. When we get that 6x in the middle, we're doubling that 3, but basically it's because we're taking 3 times x. So we have a 3 times x and another 3 times x, and we're making a 6x. But if that's not x, and it's now 2x, we're really taking 3 times 2x and adding that to another 3 times 2x. We've always had 1x, so we haven't really talked a lot about it, and I probably should have been all along. We're taking 3 times 1 to figure out how many x's we have. But we're just taking 3 twice because 3 times 1 doesn't change anything, right? But taking 3 times 2. So the error is she didn't take, for the middle term, didn't take that 2 into consideration. So she is correct. It would start with 4x squared because 2x times 2x does give us the first term. And the last term is given by 3 times 3. So that is 9. That's correct. But that middle term comes from multiplying these 2 terms together twice. So you got 3 times 6x, which is 6x, and then another 6x because it's squared. We have 2 of those. So this middle term would actually be 12x. She's only got 6x. There's 2 of those. 2 of those. We got to remember, we've got to multiply it by 2. So we're going to practice some of that today because we need to learn how to do that when the coefficient is not a 1. We've been dealing with a lot of the 1x squareds. Now we're going to deal with some numbers that are not a coefficient of 1. So let's go down here and let's just practice writing these in standard form. All right, so taking the binomial squared, so the binomial times the binomial, 4x plus 1 times 4x plus 1. What would that look like in standard form? Okay, that first term we said is 4x times 4x. 4 times 4 is 16. X times x is x squared. Okay, and then let's go ahead and get that last term. I'm going to skip the middle term. 1 times 1 gives us the last term. It's just the constant, just 1. But to get that middle term, we multiply these by each other. And then we add that together twice. 1 times 4x is 4x. And since we need 2 of those, we have 8x. So that would be 16x squared plus 8x plus 1. So what would this be? 5x times 5x. 25x squared plus something. Negative 2 times a negative 2. Positive 4. So I know there's going to be a positive on the end. But look at this. Negative 2 times 5x is what? Negative 10x. And since we have two of those, this is not going to be a positive for that middle term. All right, we're looking at a minus 10x minus 10x minus 20x when we add those together. Now you may be saying, why do I have two of these? What do you keep saying we need to have two of them? Let's work it out to where if we used the box method to distribute. We're just distributing. We're distributing here. And we're distributing 5x. Ooh, that's not a good 5. Kaya is going to holler at me. All right. 5x minus 2. 5x minus 2. So when we do that with the box method, and there's other ways to distribute, you can put the parentheses side by side and do the distribution property. But doing this, 5x times 5x is 25x squared, right? What is negative 2 times 5x? That's negative 10x. What's 5x times negative 2? Negative 10x. Negative 2 times negative 2 plus 4, right? So when we write all that out, we just take these and add them all together. 25x squared minus 10x plus 4. So where I said we need two of them, that's what happens when we do the distributive property. Woo, chocolate. Can't talk now. The distributive property is going to give us that middle term, and when we're doing a number squared times itself, that middle term is going to be the same number twice. So negative 10x, negative 10x. That's why I'm writing it twice over here. So I'm not going to do this every time. I'm showing you how we get that. And we're just going to use the shortcut of knowing we need two of those multiplied times each other. Because that's what happened. 5x was multiplied by the minus 2. 5x minus 2 in each of those boxes. And that's how we were getting that middle term. So if that confuses you, come back and review this. All right, see what we're doing. All right, let me set that on my chocolate bar and let's move on to the next one. Okay, decide, if that is in focus, decide if each expression is a perfect square. If it is, we're going to write an equivalent expression in the form of kx plus m squared, the binomials, right? The binomial squared. If not, suggest a change to make it a perfect square. So we know that this is going to be the first term of the binomial will be the square root of this. What would be 4x squared? What do we need to multiply by itself to get 4x squared? Well, 2 times 2 would be the 4, and x times x would be the x squared. And then the last number in the binomial, this m, is going to be from the number that multiplies to be the 9. So that would be plus 3. So it should be 2x plus 3 squared as a binomial. Is this middle term correct? That's what we need to see. 3 times 2x. What is that? 3 times 2 is 6. 6x. If we have two of them, this one works. This is a perfect square. No changes needed. Got it. Pardon me. All right, let's check the second one. So again, we have the same 4x squared. So we know again this is going to be a 2x. But this time we have a 25 instead of a 9. So 5 times 5. All right. We could say also it's negative 5 times negative 5, which is a possibility. But since this is showing to be a positive, we know we have to use the positive 5. This tells us right here, the middle term will tell you if that's a negative, we should be using the negative 3 times negative 3 or the negative 5 times a negative 5 if that is a minus. But it's not, it's a positive. So we're using the positive right here. So is 8x the correct middle term? 2x times 5, 5 times 2x, 10x. And if we have two of those, that should not be 8x. All right, that should be 4x squared plus 20x plus 25. That is the equivalent standard form expression of 2x plus 5 squared. Okay, see that? Again, using that middle term, checking it. So we're kind of checking it different directions. So let's see right here. This is the last problem that we do. I'm trying to keep these videos short and to the point because you can always go back and review them. If If I went through it and you didn't get it, I'm not going to do 3 and 4 examples necessarily of everything, because you can always back up and see the examples I did again. And so I'm trying to save some time that way. There's no need to make you watch 3 or 4 if you get it the first time. All right? But if you didn't, you have the option to go watch it again. All right, when all the stars align. So find the value of C. Oh, we've got to find that constant term in each one of these. And to make that a perfect square in standard form, and then write the equivalent of the squared factors. So we've got to finish the trinomial and then write the binomial that'll be squared. So we have enough information to do that. This time, changing it up again, we have the first term and the second term, and we're trying to look at the third term. The last problem, we had the first term and the last term, and we had to check see if the middle term was right. So we're kind of playing it from different angles just to make sure we understand it. So we know for sure that the first term has to be 10x, right? Because that is 100x squared. And we know down here 36x squared is going to be 6x. We know here 25x squared is 5 times 5. And 0.25x squared. What multiplies by itself to be 0.25? 0.25 is 1/4. It's, what times itself. In this case, it's 0.5 or 1/2. 1/2 times 1/2 is 1/4. 0.5 times 0.5 is 0.25. So that is the first term. And this is a positive. That one's a negative. That one's a positive. That one's a negative. So we need to find the number to put right here that will make this to be an 80. All right. And then we'll figure out what the C needs to be also. So to get 80, we multiply this number times this number and then add it to a second one of exactly the same number. So half of the 80x would be 40x, right? So we need to be able to multiply these two numbers to get 40x. We got 10x, so if we have a plus 4, 4 times 10x is 40x. If we had two of those, a 40x and another 40x, that would be 80x. So that is the number we're looking for. So what is C now? Now that we know that it's plus 4, we square that. 4 times 4. So C would be 16. All right, taking out the C, it's 16. So 10x squared plus 80x plus 16 is the same as 10x plus 4 squared. Okay, not too bad. All right, let's try the next one. Minus 60x. All right, so we have two numbers that are the same that would add up to be minus 60x. So it must be minus 30x and minus 30x. We just cut it in half. So we need minus 30x to be the number we get when we multiply the two terms together from the binomial. 6x times minus what would give us minus 30x? Five, right? Minus 5 times 6x is minus 30x. So if we had two of those, that would be minus 60x. That is the binomial. What does C need to be? Let's take it. C minus 5 times minus 5 plus 25. No, so these are all pluses because it doesn't matter if that is a plus or a minus. When you square it, when you multiply it by itself, it's going to be positive because a minus times a minus is a positive, as well as a positive times positive. So, okay, plus 16 plus 25. How about this one? 40x. So it must equal 20x when we multiply it together. We've got 5x. So 5x plus a 4. 4 times 5x is 20x. Two of those would be 40x squared. But there's a minus 6x. So it should be minus 3. So 0.5 times what would be minus 3? 1/2 times what? Minus 6. All right? Minus 6 times 1/2 times 0.5 would be minus 3x. And so minus 3x and minus 3x would be that. So, all right, so we got those. Let's figure out what these last two C's are. 4. 4 times 4. So that one's 16, just like the first one is. Minus 6x plus minus 6 times minus 6, 36. All right, that's how we do the perfect square trinomials. Change them into the squared binomials. I want to go over, I have Jeffrey! Jeffrey! I lost the camera.
Lost it?
Yeah, I was right at the end of the algebra lesson. It's almost at the end. But the camera, I heard it click.
It's still there.
Oh, is it still there?
Yeah.
What was clicking then? Something clicked like it clicked off.
I just don't know.
Okay. Well, whatever it was, then you can just edit this out. So, sorry. I didn't go away, but it clicked like it turned off or something, like a shutter closed. You know?
I would have thought it lost it too.
Yeah. All right. Sounds good. All right, I have the problems here. I want to go over those with you real quick. All right, let's see what you are doing in today's assignment. Select all the expressions that are perfect squares. You're going to check them just like we just did on the problems that I showed you. You're going to take half of that. Well, not the half of that. I'm sorry, the square root of that. What number would multiply by itself? Let's do the first one. 3x times 3x would be 9x squared, right? And what number to go with it? This is a positive, so it's going to be plus something. What multiplies by itself to be 16? 4, negative 4. We're using the positive one because of the middle term. So if that is our binomial, is that the correct number? That's what you're checking. You're taking 4 times 3x, and then say if I did that twice, would that add up to 24x? Spoiler alert. It does, because that's 12x. 12x is 24x. So that should be one of the ones you select. It says select all. I see a lot of you on select all are selecting one. When has an assignment ever on any test or anything said select all and there's really only one answer? Very, very, very rarely is there only one correct answer when it says select all. So, a little test taking tip for you. Anytime it says select all, look for more than one answer. All right, find the missing number that makes the expression a perfect square. Oh, perfect. You can make the binomial right there. 7 times 7 is 49. X times x. This is a minus. What times itself equals 16? Must be minus 4. That is the binomial. So when you multiply those together twice, you have 2 of those. What number needs to go there? All right, do that on those 4. Good practice. Get that going. Find the missing number that makes this a perfect square. Oh, this is the same thing, just a little different order. We're giving you the first one, right, which would be 2x, because 2x times 2x. What number, that's a plus, what number needs to be there for you to end up with 24x? You can do that. So then, write it in factored form. I've already started that right there. So one answer will be what number goes there. The other one will be whatever that ends up being. Okay. Let's see. Do we have one last problem, and this is for each one. Decide if f of x. This is kind of a review question. I don't want you to forget this stuff. F of x. This is the graph of each f of x. Does it have 0, 1, or 2 solutions? Right. So what is a solution? Remember, a solution is when the equation equals 0. When the equation equals 0. So that's a big hint. When does the graph equal 0? That'll tell you, does it have 0 solution, 1 solution, 2 solutions? Because how many times does it equal 0 when you graph it? So, all right. That is it. I hope you had a great Easter. Hope you don't have a whole lot of trouble with this. We are online. We're online every day. Mrs. Smith is online. I'm online every day during the week. Fridays for extended tutoring time. Mrs. Smith has times that she allows you to sign up for like a 1 hour by yourself tutoring session. In our chat rooms, a lot of times we don't have more than one person. A lot of times we have 0 students in there at any time. So it's almost like a private tutoring session itself. And maybe there's one other student in there when you come in. And so what I've seen so far, when a student comes in, when there's already another student, they've been working on the same assignment. And it's helped both of them. One of them doesn't even have to talk. The other one does generally. But come on, see us. I don't want you to struggle with this. Make sure you're watching the videos. Check the email I sent if you haven't looked at that already. Big difference. The scores of the people that are watching the video, scores of the people not watching the videos. All these are grades. These are counted as attendance, and they're counted in the grade book. Don't miss out. Don't cheat yourself. All right? Do work that you can be proud of. We'll see you next time.